Ria, welcome to Stories in AI. How are you today?
Very well. Thank you so much, Ganesh, for this opportunity to be on your show.
Oh, it's such a treat to have you on the show. I know we've been talking about it and scheduling and rescheduling and dealing with climate action, everything to get to this point. But I'm so glad you could take the time, and I'm really, really grateful for that. Why don't we get started and start us off by telling your story, your personal story.
Sure. Well, I am Indian, but I was born in Trinidad and Tobago. And so that used to be a British colony. So the British colonized people in Trinidad and Tobago from India. So I was actually born in Trinidad and Tobago. And then we immigrated to the United States when I was a child. And so I come from very, very humble beginnings. You know, we were part of the immigrants who migrated through Ellis Island in New York and, settled in Queens at the time. And as I was a child, even though, my family has nothing to do with the sciences, really, I just got this interest in astronomy and learning everything I could about it. And my first aspiration when I was, like 5 years old, I wanted to be a clown when I grew up. And so I saw Ronald McDonald at McDonald's, and I said, that's what I want to be when I grow up. Maybe I could be Bozo or Ronald McDonald or something. I thought that seemed like a really great thing to be when I grow up. And my family, it's sort of a stereotype, the Indian family who always wants their child to grow up and be a doctor.
Yeah.
They'd say, don't you want to be a doctor? And I said, no, I want to be a clown. And I was dead serious. They weren't having it. But then it almost went from crazy to crazier because, soon afterwards I said I wanted to go to the moon. And they said, so the family reunion, they'd come together. What do you want to be when you grow up? I said, well, I would like to go to the moon.
I would like to be the first clown.
None of the, yeah. So none of these things went down very well. And, I definitely met with some resistance as I was growing up. But my mom she was starting to see the light. Okay. She's into science. All right. I don't know anything about it, but we'll try to support this. And so as I grew up, I entered, really how it was for me, I entered a lot of science fair. And so I started with science fair. Whenever they'd make it available, I'd always enter science fair. And I did really well with science fair. I was always doing some crazy research project, and people were very impressed with it. And so it took me places. It was science fair that took me, into that world of scientific research. And so I ended up, I went to Boston Latin School in Boston, and then you fast forward. I ended up going to Harvard early as a young teen, taking classes there when I was 14. As a matter of fact, I had exhausted my science and math. I mean, I was all into it, and I wanted to go to math camp. I was just, the prototypical geek. And so here, yeah. And it was funny because when I was 6, I wanted to work for NASA someday, which was such a moonshot. I mean, here we recently came off of a boat to come to America, and I'm saying I want to go work for NASA. But sure enough, when I was 22, I worked for NASA, and I was on mission to Mars at the time. This was the first mission to Mars, which was a really great, it was a groundbreaking project when we sent the Pathfinder to Mars. So I was a space physicist. And then that opened, one thing led to the next. I also had a stint kind of working for Wall Street companies with my math. And I also had training in atmospheric science, because by that time I had worked in supercomputing at Lawrence Livermore Labs on some of the earliest climate models that existed at the time. Very, very primitive climate models, but I was a part of, working on those. And that was the Berkeley area. This was, I'm talking 1991, 1992. This was 30 years ago. So it's been 30 years and it's been quite a journey as basically an applied mathematician, but that has taken me a lot of places. Back then, we didn't have much by way of computing. We didn't have the internet. So I saw AI grow up and I grew up with it. And, now we're doing things that I could have only dreamt of when I first got into the field 30 years ago.
That's amazing.
So that's been my journey.
I would actually also add that it's because people like you dreamt about it 30 years ago, we're able to do it today, right? So kudos to you. But, before we even dive into AI, Ria, I mean, you have an amazing list of accomplishment across. I mean, you're not just a polymath, you're like a poly something, right? Wherein, you're a classical pianist, you're a fashion model, you were Miss Tennessee, Miss America, Mrs. Grand Universe, and a weather entrepreneur, a climate entrepreneur, mathematician, the applied physicist, astrophysicist. There's like I could just spend a whole episode talking about your accomplishments. How did all that explorations beyond academics and science happen?
Well, I'm interested in a lot of different things. And some people say, well, you're like a Renaissance woman. I think there's a lot of us who are Renaissance people. But sometimes the world wants to pigeonhole us into just one thing. I think a lot of us have different aspects to our personality. I've had a lot of adversities and challenges. I've had health issues. I was paralyzed through a kind of a West Nile virus many, many years ago. I had to learn how to walk again. And also through personal circumstances, I paid my way through college and all that, held down a full-time job while going to school full-time, that kind of thing. I was, the working immigrant. And so, but I kept moving forward. And two of the things that I do is I'm a long-term thinker. Like when I started my company, StatWeather, I kind of mapped out a 15-year vision. And though it was a real zigzagging path, it really, things really came about. And so I think decades ahead, I really do. And I'm very patient. That's the other thing. I take little baby steps. If I want to get through a 1,000-page book, I just start and I read half a page a day. I'm the tortoise,
Got it.
And so that's how I get stuff done.
It is amazing. I mean, it's a very, very rare trait, and of being able to think that long term, right? And but one is the fact that everybody says people really underestimate what they can do in the long term and overestimate what they can do in the short term, which is so true, right? And if you really realize that the long term is a real game, then you can really, really push forward and make arch defining changes, if you will. And the second thing I like, you mentioned you're patient, and I like to, tell people and to myself a lot, right? Impatience for action and patience for results, right? So that's the right way to do it, because otherwise you go crazy if you're waiting for things to happen. You don't have the patience. But if you have too much patience and you're really not adding in the sense of urgency to getting things done, that is also not too good. So pretty amazing background. And I'm so honored to have you on the show.
Thank you, Ganesh. Honored to be here with you.
So Ria, you're a long-term thinker, and this is the show about AI and about people who make AI happen, right? What do you see the role of AI in the future of humanity? Play us forward another decade, as you like to think through.
Well, I recently learned about a project that's getting started, and this gives you an example of where I'm seeing it going and where I would like to see it go in the decade ahead. There's something called Deep Time Digital Earth, and that is an international work of geoscientists. And what they're doing is they're bringing all this geoscience data from all of these disparate sources. And, it's kind of like the grand database of geoscience. And if you have all of this data in there on everything from climate to the different layers of the earth that go back in deep time, billions of years ago, things that they can dig out from fossil records, you have this grand database, then using AI, then we could track back all sorts of things like, the evolution of humanity and the cultures of humanity and things that we answer only in little bits and pieces now. But through AI, we have the capacity to do big science, big data and big science to answer very big questions about even our own origins. And so I'm looking forward to big projects like that AI can help us towards getting to that knowledge. It also helps us get to the knowledge of climate change and its impacts. And so, for example, I've been studying what does it mean when there's more carbon dioxide in the atmosphere, and what happened in epochs past when you had a lot of carbon dioxide in the atmosphere. And what happened, people say, well, actually CO2 is good for life on Earth. It's good for some life on Earth. Back in those days, in those, in the paleoclimatology, snakes were the size of your house. Reptiles were enormous. And mammals were small. Horses were this big. So, things were quite different during these times of different, atmospheric conditions. But you see how AI, if we have the big data and the big science and the analysis, we can help understand these things and what the implications are and what, where humanity is moving towards. So I'm talking about AI from kind of answering big scientific questions. People use AI for all kinds of applications, including, a dating app and finding a date, but I'm kind of talking about it from like these big,
existential questions, right?
Questions.
No, and I tell you, I like to joke around this. There's like half of AI research. It's all good, but the real aptitude of the real opportunity with AI and machine learning and these deep is to do those deep science, ask those tough questions, understand the world as we take off our little myopic microscope and then start looking at the bigger picture and understand all the nuances of the data around, right? That's where the power of this comes in. That said, almost half of the research dollars that go into AI is powered by online shopping. That's the unfortunate truth,
Yeah.
right? Because of all the recommender systems, everything. But it's
That's
actually,
right.
your notion of one of the things I've been passionate about. I've been in AI for as long as I remember now, and one of the things I'm really passionate about right now is how do you really apply these to really big problems, right? Health is one. There's a lot of opportunities and things that you can do better in health. And unfortunately, healthcare is a really dated system. So there's a systemic challenges that you got to actually go to transform it. But with AI and data, you can do that. Same with climate, right? Or anything to do with our existential questions, understanding the nuances and so forth. And it's the good and the bad news is it is always a search for a needle in the haystack. And the worst news is actually it's always an evolving haystack because the amount of information being generated every day is also going through the roof. So we have completely surpassed the human ability to just understand everything that's happening around us a while ago, right? So you need these powerful augmentation tools like machine learning, like analytics to augment those, to answer those bigger questions, if you will. So I'm so glad you're actually excited about it, and I'm sure you're doing something about it. And I want to get to that in just a minute. But before that, tell us about StatWeather, right? Weather prediction. That's as I understood it, right? Weather prediction, age-old challenges. Climate modeling has always been a big issue. We're still not really good at it in predicting weather in shorter time frames, right? Over periods, yes. You can predict temperature changes over the next decade and so forth. But the smaller time frames, it becomes a really harder problem. It's a multivariate problem. Tell us about what StatWeather's mission is all about. What have you been doing in this space, and how does AI and data play in this space as well?
Yes. Well, with the current weather prediction, like if you go online and you look up the Weather Channel's weather forecast. Those forecasts are based upon government models, and government models are based upon the physical dynamics of the weather system. And so you have, it takes the current state of the atmosphere, it takes that observation and then plugs it into these equations, and then it gets a future state. So it doesn't take into account patterns or, historical data. So I was finding that in industry, people have a real knowledge gap. They really want to know the weather, or it's that intersection between weather and climate, maybe 2 months ahead or 3 months ahead. The thing is, you can't say exactly what's going to happen 3 months ahead. That would be a deterministic forecast. You can't give someone a number and a moment and say this is going to happen. But there's something called a probabilistic forecast. Yep. I could say to you that within this time frame, there is a 75% chance of this range of scenarios happening. And that is very useful information in the long term. And what we also find in the historical patterns is that some things repeat themselves with certain predictabilities in different areas. And so it's using data. It's using this kind of data science, big data mining approach. We use Bayesian networks, which is different from neural networks, a Bayesian network approach, to come upon these correspondences, these patterns, what triggers there are to heat waves and cold snaps and droughts. What are the triggers? What might happen 3 months ahead that then kick you into this down the road? So that's what StatWeather does. And it was new because that's not the methodology that's invested in currently by these big government weather models. And so we were able to fill a gap. The government weather models are great for that short term, what's going to happen? Is it going to rain tomorrow kind of thing? But for giving people that longer term risk, that's where StatWeather came in to fill the gap. And so for 10 years, we had been operating basically in the space, which is, we cater more to the energy and commodities industry. If your forecasts are wrong, or if they'd be better off with a coin toss, you go out of business in about a year or two. So it's worked. We've had repeat customers, for a decade, and it's been a really great, it's been a great tool for a lot of different companies and industries, particularly in the energy and renewable space. Ganesh, I can't hear your sound.
Yeah, I'm back on. Sorry. I had muted just to avoid any background noise. So your recent, we were talking earlier, and your recent exploration into these climate projects and things that you're doing. Is StatWeather looking into a newer way of where you're going from here, like into weather, beyond just weather prediction to climate prediction, action, that kind of stuff? So tell us a little bit about what you're thinking.
Yes, StatWeather, this type of solution can be scaled even for climate modeling. It can be scaled for different applications. And then also weather can slot into a lot of other systems. So like in energy, you have a weather forecast, and from there they can generate a load forecast for, say, energy, for electricity. And then from the load forecast, then there's a pricing model. So it's like you go from one model and feed that into another model, and then that output goes into yet another model. So I was just speaking with someone today about the creation of an all-in-one model, and what types, can we sort of mash together all these models to create one model? And so, the answer is yes, but how to do it so that you don't lose any accuracy along the way.
Yeah, exactly. Yeah.
Exactly.
Interesting. So that's, there is a lot of effort in the AI community as well, like on the research side, just in machine learning, right? Especially in deep learning, right? Can you get to more, do operations in a Euclidean space, right? And then, about like taking into account all the different variations and dimensions of the data. And then can you solve that then because AI has a no one size fits all problem, right? Which is
No one size fits all.
right. So you're always building snowflakes and custom models to solve different problems. And one of the biggest problem is this, generalized AI, right? One of the biggest opportunities to how do you build a model that can be easily adapted, right, through different purposes, if you will. So very excited about it. Now, tell me about this new project of yours, the climate project.
Yeah, so I am getting involved with an open source project, kind of advising on a project. And this is through the Open Earth Foundation. And what they're doing is it's really about crowdsourcing data that help us generate models of the Earth, and creating a kind of a digital Earth. And so I was talking about a different project just now, something called Deep Time Digital Earth. That's the geosciences side.
Yep.
And there's also another climate sciences side called Digital Earth, which is, that people can share data and somehow be incentivized through that sharing. And so this way we get a collective view of what's happening on Earth. So the thing about this is that there are a lot of companies that have bits and pieces of the pie.
Yep.
And now there are more and more open source initiatives coming up to say, wait a minute, we need to combine these pieces of the pie. So the question is, does this cut at what the companies are trying to do? And so the open source model, the case for an open source model is that if we can agree and have, these sets of standards, then even within companies, it can make their product offerings richer and that they can monetize even on that. And we see that a lot. I mean, because there is open source weather data through NOAA, through the National Oceanic and Atmospheric Administration. That's why StatWeather exists. Mm-hmm. I mean, if we didn't have their historical data, then we couldn't operate on that data and make our predictions. So open source is really useful, and businesses can capitalize on these types of open source resources.
And you're bringing up a really good point, right? Because climate is one area, and there will be other areas like this that'll also very soon get here, where it is an existential question, right? I mean, the problem is not unique to a commercial entity, a company. It is not a zero-sum solution, right? This is it's a problem where everybody needs to put together the best of what they have to solve the really hard problem. And so it's pretty exciting what you're saying, because I think I'm hoping the output is kind of like a digital twin of the Earth with all the data that you have. So people can model and use it to study different effects at different parts. I mean, it's pretty fascinating.
Exactly.
Right. I think
whether it's biodiversity loss or whatever it may be. Yeah.
That is awesome. Now let me bring you back to AI. And we live in a world where a lot of the decisions are made, we like it or not, by AI agents and intelligent systems, almost to an extent that it tells you what to view, how to think, how to actually make decisions. I mean, making decisions for you, making crowd intelligence. So we're increasingly, being told what to think, whom to like, all those kind of things, right? What do you see as a scientist, and you're looking at it as a mathematician, and you're also involved in this field for a long time? How do you see this, benefiting / harming the society? And what kind of, there's a lot of talk around ethics and governance of AI and stuff. So give me your feel as a scientist when you think about it. When you think about this problem, is it just a cost that you have to just bear because you're getting the benefits?
So the way I think of AI, I'm a mathematician. I think of it as benign and as neutral as algebra. I mean, it's a technique. It's a mathematical construct. There is nothing bad or good about it. It's just like saying geometry or trigonometry. It's a part of math. It's a technique, a class of techniques. So it's not, AI is not a problem, but it's about how people use it. It's about the applications. And so, you talk about regulating AI. There is nothing to regulate as much as regulating fractions or algebraic equations. I mean, there's nothing to regulate there. It's regulating the applications and how people are using it, the human side of it. That's, where the regulation comes in. And so on the human side, what happens is that in order for people to, use AI to, make predictions, there's all this data collection. So then there's the ethics on data collection and our privacy. I always seem to be appalled by, like, how did they know that about me? You go online and suddenly these ads come up or something. It's like, what are they fishing through my email inbox and everything to show me all this? So that's one thing, is the privacy of just simply the data collection. And then another risk with AI is the inaccuracy in prediction. And especially if we're going to use it for mission critical type stuff or things that involve public safety. So we have to really get a handle on that to build trust in these types of systems. And there are, to this day, things that AI cannot do that you think that it could do. One of them is finding exoplanets.
Yeah.
And so that's actually crowdsourced, where human beings go through tons and tons of, photographs and curate. And then the computerized digitization comes in to then narrow it down. But the human eye is still more sensitive than a machine. That is still the case in astrophysics. And I just read an article about it from NASA. It was the case 30 years ago, and it's still the case. So it can't do everything. That's another thing, is if people overestimate its abilities and think it can, solve everything. And then the third and last thing I want to point out as a risk is how AI can drive recommendations to extremes. And I'll give you an example. This is true story. I go on Instagram and I look at I love animals. And so I go on there and look at little animals. And so I look at a puppy. And what happens is the next time I log into my Instagram, it shows me puppies. And so I looked at a Shih Tzu. The next time I go on there, it's showing me some Shih Tzus. Now, the Shih Tzu that I saw happened to have spina bifida disease. It happened to have a little condition, this particular Shih Tzu. So you know what Instagram did? It showed me pictures of animals with this disease. And then, it goes down this route where it just goes, it sends me down this pigeonhole. Where I went on Instagram to look at animals. I didn't go on Instagram to look at spina bifida disease. And so, but this is what happens, you see, with this engine. But then think about it with our kids. They click on something, maybe there's something very unsavory in what they click on. And then it keeps showing them the ugliness, and it goes into this pattern of uglier to ugliest. And it keeps going like that. So that can be a real problem.
Yeah, no, it's actually, I mean, you nailed it. The challenges, and if I may rephrase it, right, one is about the people. It's not so much about the technology, but about the people who hold that technology and wield that influence over others. So things like, are you using ethical practices to collect the data? Are you actually making recommendations? The second thing that you said is the applications itself, right? Some applications are great fit for AI. Some applications are not. I love the exoplanets example. And then lastly, it's the outcomes of the recommendations and the impact of that. To me, that maps back to accountability, right? It's less a problem about don't make that recommendation, but if you make that recommendation and, the kid just goes into this depression because of that, somebody needs to be held accountable because it was your algorithm that you designed to optimize for the clickbait and, the reinforcement that is happening when people click on the same thing. You're optimizing for a technical outcome and it's having an impact in life and in people. That linkage needs to be governed pretty well, right? So I think that's an interesting way to say it. I couldn't agree more. I think this is it's fascinating how you actually called it out, and it's already seen. We're seeing the Cambridge Analytica example from 4 years ago, and we're still seeing the case of fake news everywhere. And you can't trust. I mean, it's caused a big. I mean, we're on the point in crisis so much that Mark Zuckerberg is trying to rename Facebook to something else, right? So he thinks that's going to solve all the problems. But anyway, so let me touch a little bit more on space and astrophysics and, just in general, like space tech, and there's an arms race going on there, right? One from getting all the space junk up there and a lot of satellites and commercial and others on one end. The second is space travel, is all this beyond just the recreational travel, but it's going to actually drive the dollars to actually boost the real challenges. How do you see all the space work that is happening, space tech innovations that are happening right now? Do you see that as a distraction? Do you see that as a way towards furthering the larger purpose, which is how do you make life more, meaningful for everybody? How do you elevate the human experience? How do you see space tech as a physicist and an astrophysicist?
Well, I grew up in the 1980s, and it used to be that space was mainly in the context of Star Wars, of, you had the Iron Curtain and all of, kind of the Cold War and these types of applications. And so we were sending rockets out sort of to assert a kind of ascendancy, a technological ascendancy, and also to explore. But it was, a little bit more now. And now things have just broadened out. Now they're looking for life on Mars. They're looking for, on that brink of space, like space tourism.
Oh, yeah.
We're looking at mining of asteroids. We're looking at, all of these different things, answering existential questions. Also, my favorite application, though, is satellites and just the monitoring of the atmospheric conditions and how we can help life on Earth. So monitoring what's going on in terms of our, what's going on in our atmosphere, how is that going to help us on Earth? So I'm not so much in favor of surveillance of people. That's the thing. I mean, these high resolution satellites, that's a whole nother aspect of it. And it's a sort of a necessary evil, I would have to say, that people do this. It's just a part of the fabric of the world that we live in, to monitor different things that are going on, to protect your territory and all that kind of stuff. And I'm not so much into that, but just there are so many applications now. It's hard to remember. And I think it's because of now our capabilities, our computing capabilities are massive. So we can automate so much. And there's that whole automaton. Now we can send robot, on Mars and dig stuff up and have a little helicopter, on a planet and collect data for us. So all of these technologies have opened up space, but I'm still wondering how we're going to get past the barrier of the speed of light and go visit Andromeda and, decompose ourselves in a quantum way and then, warp ourselves into another galaxy. I'm still wondering about that.
Do you think human beings will be a multi-planetary species sustainably? I mean, not just visiting for tourism. Do you think we will really go and settle down and have a human settlement in Mars and other planets?
Well, I think that scientifically it can happen. I mean, you can develop technologies like with plants that grow and that supply your oxygen. So scientifically it can happen, but it's really expensive. I mean, I feel like the world is going bankrupt in a way. Economically, there are so many problems to take care of. I don't know, who's going to fund up all of these missions to try to have a whole settlement in outer space when we can barely afford to feed people on Earth, So that's the thing. So, yeah, I mean, scientifically, yes, all these things, you can work it out. But, these things are billions and billions of dollars just to execute one type of a mission like this.
Yep.
I don't know. I think there's going to be a lot of fallout because already now people are complaining about space tourism. And they're like, why don't the billionaires spend that money to, help life on Earth? So I think that's going to be a big fight.
I think so too. And it's funny you actually say that, I got one answer who's going to pay for all that shopping we do and the AI research that it gets, all that's going to go fund that thing. But it's a fascinating time we live in, right? Where all of these are like you said, I grew up, when I was growing up, going to the moon was the biggest thing we ever did. And now we are talking about visiting Andromeda and, using warp drives to actually transport us through the quantum, universes. And it's fascinating how to, my view of this is at some point we'll all realize that, okay, all of this doesn't make any sense. It's all up here or in here. So you just need to close your eyes and then imagine the galaxy, the universe that you want to, and then you can live it'll be the true metaverse, not the one that Facebook is trying to build, right? So where all of this, we'll probably realize that, look, it's all in here and then around us, right? The universe is in your head, right? So anyway, Ria, this has been fascinating. It's a very interesting conversation. You're also involved, the European Union, in helping organizations. You're the president of the Digital Initiative, right? And what is your advice to organizations, startups, companies who are looking at digital transformation? How do they embrace? What are the things that you've seen, and what is your advice to them?
Well, you touched upon something earlier, which is that no one size fits all with AI. I'd like businesses to know that it's not just saying, oh, let's just go get an AI. And AI is a whole collection of different techniques and methods for automating, predicting, digitalization, with a lot of different aims. It's a field. And so it's important to onboard the right expert to advise that company on what to use or if it's even needed. I find a lot of people would be better served just to use a statistician, rather than trying to kill a mosquito with a blowtorch and build an entire, neural net system overlaid on top of some other system, all of this stuff, which is fine if you need that. And so I just want to advise businesses that this is a very nuanced field. It's also, even though AI has been around a long time, in some respects, it's still in its infancy. It has a long way to go as well. And so in the educational system, even though it's moving with breakneck speed, teaching people data science, there are still things not in the educational system that they're not teaching that, people are using in the business sector as well. And so Bayesian networks being one that's not quite ingrained. There's another category of AI called active inference that's not taught. And it's because it's so new. These are things that in the last decade, the mathematical frameworks were developed. And so it's constantly evolving with greater and greater technology. And so I just want businesses to realize how nuanced it is. And, just because you went out and bought a package that has the letters AI on it, it takes expertise to know what to do with that.
Yeah. My personal critique on AI has been 20, 30 years ago, AI was all about symbolic logic, right? It was all about capturing the human knowledge and then translating that as rules and then automating those rules, right? I mean, the CICS project in Austin, for example.
Yes.
And then now, the last 10 years, you can't really write rules for all the explosion of data that's happening. So we invented these amazing techniques, statistical techniques primarily, but also into the realm of NLP and computer vision and deep learning, especially, really exploded in helping us really understand a larger volumes of data. So the things that you cannot do through rules, now you can actually train models, go into black boxes and understand the relationships and come up with the functions, right? I think we swung the pendulum a little to this side. Right now, everybody is I have historic data. I'm just going to run a regression model to see what comes out of it, right? And you lose the expertise aspect, as was heavily influenced earlier on, but not so much data-oriented. Now we have data-oriented or data-driven machine learning, but the merging of the human expertise. And, it's catching up in pieces, like things like data quality management and data management is now everybody's realizing that, I can't just store all the data and expect it to magically work. Somebody needs to understand, what does it say? What's the dictionary? How does one piece of data connect to another? What's the relationship between them? All of that are now being, operationalized through information management practices. So I think that's helping a lot. Ria, this It's been fascinating. We touched so many different things, and I can still go on. I have two quick questions, rapid fire questions, and then I'll let you go. One is, do you believe in artificial general intelligence? Is that going to be possible in our lifetime? AI still can't, look at exoplanets and identify them. I know that, but do you believe in AGI? Are we going to see that in our lifetime?
I know that there are people, there's a whole school of thought that there will be a singularity where AI basically can become conscious in some kind of way. And I haven't quite stretched my mind around that yet. And because I still think that we don't have a good model of what even consciousness is, even though some people think that they have the right model. So me, no, I say no.
Okay.
I think we'll simulate it, but I don't know. I don't think that it would be the real deal.
I recently had someone send me a note saying we have figured out a way to actually induce consciousness in machines. And I'm like, okay, thank you very much. Technical literature, right? So second question is, what is one power practice, personal power practice that you employ that, you attribute to your success, sanity, whatever, right? What is one personal power practice?
Well, it's more of a philosophy, which is, it sounds so cliched, but just stay calm. I'm a very calm person. And so it doesn't matter what's going on. I just think that if we stay calm, that the answers tend to come to us. We can think better and think outside the box. And so whatever it takes for a person to stay calm, if you need to take a walk or take a bath or meditate or whatever, I am a strong believer in being calm.
Awesome. Stay calm and AI on, I guess, right? So, Ria, how can the viewers and listeners get in touch with you? Where can I find you on the internet?
They can find me. Actually, I love connecting with people on LinkedIn.
Okay.
And so just go on my LinkedIn, Ria Persad. It's a public profile, and just connect with me. I connect with everybody.
Awesome. Thank you, Ria. This was a blast. I really appreciate you taking the time today. Thanks for getting on the show.
Thank you so much, Ganesh. Really appreciate this conversation.